Algebra 2, Target 30. I can graph rational functions. Today we're going to look at functions of the form y equals ax plus b over cx plus d. You'll see it in the form it's written a lot. You'll also see it written like this a lot. They're the same form, just aesthetically just a little bit different. Now if you remember graphing yesterday, we always started by plotting our asymptotes. Well, in the form we're at today, it's going to be just a little bit different to find our asymptotes. A vertical asymptote was a shift left to right yesterday. Today, we're going to look and see what makes the denominator 0. You can't divide by 0, so whatever makes the bottom 0, that's an asymptote. Right? So you set the bottom equals 0, and basically it ends up getting your vertical asymptote is negative d over c. For your horizontal asymptote, you're going to look at your lead coefficients. As long as the powers are the same, you can divide the lead coefficients. In this form, our horizontal asymptote is going to be a over c. Right? So we're going to do the same thing today. We're going to find our asymptotes. We're just using a different method. And then we're going to plot a few points on either side. So we'll start with this problem. Find our asymptotes. We'll start with our vertical asymptotes. What makes the bottom 0? X minus 3 equals 0 when x equals 3. The horizontal asymptotes, take your coefficients, your lead coefficients, and as long as the degrees are the same, you can divide those. 2 divided by 1, our horizontal asymptote is 2. So our vertical is at x equals 3. Our horizontal is at y equals 2. And now we just need to try a few points on either side. Our asymptote's going to be at 3. That's going to be undefined. We'll try a couple smaller than 3 and a couple larger than 3. All right, so when x equals 1, we got 2 times 1 plus 1 over 1 minus 3. That's 3 over negative 2. Y equals negative 1.5. When x equals 2, we got 2 times 2 plus 1 over 2 minus 3. That's 5 over negative 1. That's negative 5. When x equals 4, 2 times 4 plus 1 over 4 minus 3. That's going to give us 9. And when x equals 5, 2 times 5 plus 1 over 5 minus 3. That's 11 over 2. That's 5.5. Plot the points. 1, negative 1.5 is around here. 2, negative 5 is here. 4, 9 is here. And 5.5 is there. Connect our points. And there is our rational curve. All right, so let's find the asymptotes on this one now. Y equals x minus 1 over x plus 3. Our vertical asymptotes, what makes the bottom 0? In this case, when x is negative 3, our bottom is 0. Our horizontal, as long as the powers are the same, we can divide the lead coefficients, y equals 1. So we can plot those. X equals negative 3 is right here. Y equals 1 is right here. And now try a couple points on either side of the vertical asymptote. Vertical asymptote's at negative 3. We'll go 2 smaller, negative 4, negative 5. Negative 2, negative 1. And when we try negative 5 minus 1 over negative 5 plus 3, that's negative 6 over negative 2, so that works out to 3. Try -4. -4 minus 1 is -5. -4 minus 3 is -1. That becomes 5. Try -2. -2 minus 1 is -3. Over 1, we got -3. And if we try when x is -1, -1 minus 1 is -2. Over 2, that's -1. We've got our points. Let's plot them. -5, 3 is here. -4, 5 is here. -2, -3 is here. And -1, -1 is there. So there's our graph approaching the asymptotes in these regions. Y equals 2x plus 1 over 4x minus 2. Pause, try this on your own, and then watch the finished version. Vertical asymptote. What makes the bottom 0? The bottom is 0 and x is 1/2. A horizontal asymptote. Divide your coefficients, as long as the degrees are the same. Y is 1/2. So we'll plot our vertical at x equals 1/2. We'll plot our horizontal at y equals 1/2. And then we'll make a table. Our vertical asymptote's at 1/2. That's going to be undefined. Then try a couple points on either side. They don't have to be fractions. I'm just going to go 1 and 2 on one side, 0 and -1 on the other. And then just start plug and chug. 2 times -1 is -2 plus 1 over -4 minus 2. We got -1 over -6. That's about 0.1. If you try 0, basically the x's cancel. We got -0.5. If we try 1, 2 plus 1 is 3 over 4 times 1 minus 2 is 2. That's 1.5. And if we try 2, we got 4 plus 1 is 5 over 2 times 4 is 8 minus 2 is 6. 5, 6 is about 0.8. So those are our points. Let's plot them. -1.1 is right around there. 0, -0.5 is right around there. 1 and 1.5, then 2 and 0.8, and we got our graphs in this region right here. One more. Give this one a whirl. Try this one. Vertical, what makes the bottom 0? The bottom is 0 and x is -1. Horizontal, the degrees are the same, so I can divide the lead coefficient. Y is 3. X is -1 comes through here. Y equals 3 comes through here. Try a couple points. Our asymptote's at -1. We'll do a couple smaller, a couple larger. If I got -3 in there, that's 9 plus 2 over 2. 11 over 2 is 5.5. I got -2 in there. 6 plus 2 is 8 over -2 minus 1. -2 minus 1 is 1. So that's 8. If I throw in 0, we got -2. And if I throw in 1, -3 plus 2 over -1 minus 1, that's -1. Over -2, that's 0.5 or 1/2. Plot the points. -3, 5.5 is here. -2, 8 is here. You can see this region connects up like that. 0, -2 is here. And 1.5 is there. This region connects through like that. So, in conclusion, graphing rationals of the form ax plus b over cx plus d is the same as what we did yesterday. The only difference is we find our asymptotes in a different way. To find our vertical asymptotes, what makes the denominator 0? To find our horizontal asymptotes, this is kind of wordy the way I wrote it, but basically you divide the lead coefficients as long as the degrees are the same. And we're not going to give you one early on where the degrees are not the same.